Black holes. They're easily some of the most dangerous things reality has to offer. Planets, stars, solar systems, you name it. They all must obey the black hole. But with great power comes greater misconceptions. Misconceptions you've likely been told. With that, I welcome you to Black Hole Basics. Glad you're here. Take a seat and enjoy. First off, the name is a lie, right off the bat. Black holes aren't actually holes. Let me explain. To put it simply, there's a super dense object in the very center of every black hole. The name of this space anomaly? The singularity. The singularity is an immense amount of mass condensed into an infinitely tiny point. To better understand this, think of it like this. Imagine you pick up 2 handfuls of snow, and you want to make a snowball. What do? Simple. You crush the snow into a smaller, more compact ball, creating what the locals call a snowball. Bada bing, bada. But what if we could go further? What if we could make a snowball with the same amount of snow, even smaller and even more compact? We crush it more and more until eventually it can't get any smaller. The amount of snow hasn't changed, but the space that snow takes up has lowered, meaning its density has increased. Well, the singularity is that infinitely dense snowball in space. This singularity is usually created from the mass of a gigantic star, much bigger than our sun, collapsing in on itself and condensing. But this isn't like any old boring supernova. Ew, no. If the star is big enough or the power of the collapse is powerful enough, things get out of hand. It begins to bend the rules of space as we know it and crushes its own mass into an infinitely small point we call, say it with me, the singularity. So, the singularity is, by far, one of the most mysterious and destructive things ever. An anomaly, an enigma, never to be understood. But just when things couldn't get crazier, they do, every time. The singularity is the only physical part of a black hole, which means no one has ever truly seen what a black hole is. We only see the singularity's effects on the space around it, which means technically a black hole isn't even black. What we perceive as the dark surface of a black hole is only the event horizon, which is practically an illusion. Hear me out. The event horizon is the black sphere that shields the singularity from view. This thingy right here, look at how pretty it is. It's there because of one thing and one thing only. Gravity. Here's the thing. Because the singularity is extremely compact and dense, it has gravity so strong that it's capable of doing something no other phenomenon has ever done. It's one of many reasons black holes are able to practically say, "Nuh-uh," to human discovery. It overcomes the speed of light. An astronomical feat that's nothing to be taken lightly. You get it? No? Okay, moving on. But what is oh my god! But what does rivaling the speed of light mean? It means the gravity of a singularity is strong enough to not only pull debris, planets, and stars into its wake, but light bulbs themselves. Wait, no, that's not right, sorry. What I meant to say was light particles, commonly known as photons. That's right, the speed of light, which happens to move at a relatively slow 670,616,629 miles an hour, still fails to outpace the pull of a black hole. So, what is an event horizon, you ask? Well, it's the exact distance from the singularity in every direction that gravity matches the speed of light. No light from inside the event horizon or directly on it can escape from its gravity. This means that light never reaches your eyes, creating the illusion of a black surface in the place of the void of vision. Any light rays lucky enough to be traveling outside of the event horizon are safe and successfully make it to our eyes. But not everything that crosses paths with a black hole is lucky enough to escape, which begs the question, the big one. The doozy of all doozies that have ever been doozed. Doozy that have ever doozled? Dizzled, it doesn't matter. The question in question is, what happens when you, photons, a planet, or a rundown Taco Bell fall into a black hole? Well, that question is a bit of a problem yet to be solved. It's a problem because no information or witness could possibly escape from a black hole once they see the singularity. There's simply no way to do that without gruesome spaghettification, which, yes, is the actual term for the black hole's gravity shredding stuff into a stream of atoms while entering it. Sadly, we may never know what the inside of a black hole actually looks like or how it behaves. We honestly aren't even 100% positive what the singularity is or if it's real at all. There are just too many gaps of information we're missing, which is why black holes are so interesting. We'll never witness the singularity or the space inside the event horizon, or watch something fall into the void of a black hole, but we can guess. What do you do when you didn't study for the English test? You guess.
What do you do when someone asks if you remember their name, but you totally forgot? You guess. And what do we do when the teacher asks how to solve the equation at 8 in the morning when you are just trying to get a peaceful nap? You guess!
The most brilliant individuals and teams of astrologists and space nerds still can't crack the code of black holes, and I'm sure they won't for a long time, if ever. But you better bet I have my theories, my space theory. Despite that, the next video will focus on black hole theories others have come up with, and of course my own most likely right theories as well. I also plan to create some videos like decoding the accretion disk, what the heck is a wormhole, and other classics I've decided to gatekeep for now. So make sure to check them out, let me know what other black hole or space related videos you'd like to see, and never stop guessing until you either get it right or get told to shut up. Bye.